Hi everyone, this is Mike Montefusco, National Weather Service Wakefield Senior Meteorologist, with our latest version of Weather You Want to Know. Today we'll be discussing local winter weather climatology. Let's go ahead and get started and talk about our NOAA winter weather outlook for 2025-2026 winter. Here is the seasonal precipitation outlook, and as we talked about in the previous presentation, this is mainly a representation of the ENSO forecast going into the upcoming winter. And the outlook that you can see here is for near to below normal precipitation across our region for the upcoming winter. That's December through February of 25 into 26. And the seasonal temperature outlook is for mainly above normal temperatures over that 3-month period. As we talked about in our last installment, this is not to say that we're not going to have cooler or wetter portions of the winter. This is simply a 3-month average. So let's get into variability and talking about snowfall on a seasonal scale. When it look at Richmond in terms of our period of record for snowfall across the period of record, you notice back into the early portions of the 1900s, into the mid 1900s, we kind of had a fairly steady seasonal snowfall across the Richmond area and across our area. But we do have some periods where we did have some booms and busts in there, certainly. And the 1960s was certainly one of our very snowy decades, with 24 inches on average in the decade of the 1960s. And we did have some lesser periods with respect to snow, namely the 1920s, the 1990s, into the early 2000s. So when you look at the seasonal snowfall on a seasonal scale, it kind of brings home the point that there is quite a bit of variability that needs to be dealt with and needs to be discussed when you look at seasonal snowfall, particularly when you look at the 30-year periods. And 30-year periods are our default. Our period of record will go by a 30-year running average. We are currently in the 1991 to 2020 epoch in terms of our period of record. For all of our normals that we talk about in terms of our climate sites, we are generally in that 91 to 2020 30-year rolling period. So in terms of seasonal snowfall, the normal for that 91 to 2020 period is 8.8 inches. But if you break down the median, which is the middle value of all of those seasonal snowfall totals, that's actually at 7.8 inches. Now, what is the difference there? What is at play there? Well, if you look at some of our recent seasonal snows at Richmond, you bring those up, and you kind of look at these totals on mass, and you kind of notice there is kind of a little bit of a boom or bust to it, relatively speaking, for Richmond. But there is kind of a boom or bust to it in terms of there are some higher totals of 12 to 15 inches of snow in some totals. We had some years where we had little or no snowfall that occurred, certainly 2019, 2020, 2022, 2023, even 23, 24, where we had very little snowfall. And realize that normal is really just kind of a reflection of the extremes, and that is going to be kind of diluted or kind of clouded by higher snowfall years. So in that period of record, 1991 to 2020, there are some higher snowfall years with some lower snowfall years also thrown in there, which will kind of tend to bias these average or near the normal snowfall totals a little bit higher than what would be called median, whereas the median is just kind of the middle value here. You see the 50th percentile here would be our 50th percentile is 7.8 inches. At Norfolk, it's a very similar situation, not nearly as much decadal variation as Richmond, but you do kind of see some bouncing around with our snowfall totals with respect to the Norfolk area. The least snowy decades, once again, 1950s, then the 90s into the early 2000s, but really the decade of the 60s was on average, one of the higher periods, but not nearly as much so as it was in Richmond. But the seasonal snowfall on 30-year averages, you can kind of see it's a lot smoother versus Richmond, which kind of bounced around some. In terms of Norfolk, we've had some very big boom or bust type years with respect to Norfolk. The winter that we've just experienced, 2024, 2025, was a good example of that, where we had a rather large event by Norfolk standards, where we had 16.8 inches of snow that occurred. Maybe that January event that did the bulk of that, but certainly we've had some bigger years in terms of snowfall, with interspersed some years where we had little or no snowfall that also occurred. So again, the normal is about 6.2 inches, whereas the median is back around 3.4, which is kind of reflecting what we all kind of know after being here for a while. Certainly, we can have some years where we have little or no snowfall across the Hampton Roads area, and that's perfectly normal in terms of certainly what we've come to expect is some years where there's little or no snowfall, and some years where we do have quite a bit from an event or two or three across the Hampton Roads area. In terms of average median snowfall across our entire area, here is the breakdown. The averages are going to be in those purple rectangles, whereas the medians are going to be in the ovals, the purple ovals. And pretty much across the board, you can see the reflection of the higher snowfall totals and the averages kind of being skewed by those higher snowfall years that occur from time to time, whereas the median value is going to be a little bit lower, in some cases quite a bit lower, especially across the Hampton Roads area and the coastal plain in general. Across the coastal plain, you can kind of see that the median is up under 6 inches of snow for the coastal plain into south central Virginia, and whereas the Richmond metro area and back towards Charlottesville, Louisa area can get to upwards of 7 to 10 inches, or even upwards of a foot or more when you go northwest of Richmond towards Louisa and Charlottesville. You'll kind of note that all stations, again, those median values are going to be lower than the averages, which is again a reflection of that total, where our averages kind of get skewed by those higher snowfall years. Now let's break down snowfall versus El Nino versus La Nina, and we'll look at snowfall in the moderate to strong El Nino winters. And the key term in both of these is going to be variability, but it's kind of different flavors of variability, if you will. In the El Nino winters, the map is going to rely on the average snowfall, which can be skewed, especially in the El Nino winters that are more moderate versus strong. You're going to have higher snowfall totals on average across the mid-Atlantic region. Now, how many moderate to strong El Nino winters had below average snowfall? And you can see by these grays, these tones of these grays, very few out of 13 total of those moderate to strong El Nino years we've had in that 1959 to 2023 period. Out of those 13 winters, we had less than 4 to 6 that were below average snowfall. So this is more an indication that those moderate El Nino type winters are more of a snowy type pattern indicator than not in that setup. Now, during La Ninas, particularly weak La Ninas, as we're going into a weak La Nina in this winter, typically weak La Ninas are going to be less conducive to typical La Nina impacts, and you're going to have more reliability on teleconnection patterns. And we'll talk about the teleconnection patterns here as we go forward. But typically you can kind of see here our number of years out of 22, how many of those La Nina winters had below average snowfall? Quite a bit of them. A majority of them had below average snowfall out of that pattern. Zoom in a little bit, you can kind of see that a little bit better. Certainly a little bit more so up in the northern portions of the Commonwealth, up into the DMV region, the capital region. But certainly here in the mid-Atlantic, um, at least half or so of those La Nina winters had below average snowfall. And there is more liability on those teleconnections. So snowfall during La Nina winters typically will be below average in terms of snowfall, which again goes to that seasonal outlook. Now, is that all encompassing? Absolutely not. But that kind of goes into why it is the way it is, that outlook. So we'll look at the weak La Nina cases here. Here are some analog for previous years. And the majority of them, not all of them, but certainly the majority of them had drier than normal winters. Again, that's a 3-month period, December through February. And in each of these years, the majority of these cases had drier than normal winters. Certainly there are exceptions there. Certainly there are a couple winters where we did have wetter than normal winters in those periods. But if you look at the temperatures as well, we tend to be, on average, kind of a mixed bag in terms of temperature, in terms of warmer or cooler than normal. So we'll break into that a little bit closer, and we'll kind of look at selected analogs during weak La Ninas over the past few years here, but going back into the 1960s, going forward into the mid 20 teens here. And you can see the majority of these cases where we had very weak La Ninas. You can kind of see the El Niños index values here in the blue rectangles. And each of these is below 1. So, I mean, this is right around that weak La Nina range. The majority of these kind of featured near to below normal temperature departures. Now that certainly is interesting in terms of, kind of saying, okay, we can have cooler than normal periods during these types of setups. Where we did have one warmer than normal was in 2016, 2017. But this kind of goes to show that the forecast that we have for above normal above normal temperatures isn't really set in stone. It's more of a climatological lean in terms of what it has favored. And you go back to the previous, you can kind of see that the temperature mean is a little bit above normal, just a little bit above normal in terms of temperature, and a little bit below normal in terms of precipitation, which again is kind of going back towards what the forecast is. Is it set in stone? Absolutely not. But again, with the weak La Ninas, there is more of a temperature variability. So that high subseasonal variability in temperatures is often found in the La Nina winters, particularly the weak ones. So the weak La Ninas tend to have more variability, which is kind of what we're getting into in this pattern, where we're kind of looking at, we kind of bounce around some based upon the teleconnections. And look at the snowfall average in these analog years. Again, the boom of snow in the 1960s, you can kind of see on there at both Richmond and Salisbury, and even at Norfolk to a lesser degree. But again, on average, you can kind of see the analogs kind of indicate that we can get some snow in La Nina winters, but certainly, it is going to be, kind of variable and bounce around some, which is what we're trying to bring home in the point here. Now let's get into the teleconnections some and talk a little bit about some major indices and patterns that are used in seasonal forecasts. Now, the biggest thing about teleconnections to take home is a lot of these cannot be used on a seasonal scale. Maybe a couple of weeks to a month ahead of time, but really beyond that is going to be something where, we really can't rely on these. First, we have the North Atlantic Oscillation. This is a climatic phenomenon in the North Atlantic Ocean where we basically have the difference between whether we can lock cold air in. Now, in the positive NAO phase, we will tend to have minimal blocking. So if we have any cold air that comes in, we are not going to be able to lock that in. This is a very progressive type of pattern where we will tend to be able to have more westerly flow, which will make our weather more progressive. If we have cold air that comes in, it'll move right back out just as quickly. In a negative NAO type of setup, we have weak subpolar low pressure center kind of set up over near Greenland, and that will kind of set up what we call a Greenland block, which will kind of allow blocking to occur downstream, which if we do get cold air to move in, will tend to block that cold air in and allow that cold air to kind of set up and stay for a while. And these types of setups typically during the positive NAO is going to allow for a warmer period, and during a negative NAO is going to allow for a colder period, because that colder air, once it drains out in Canada, is going to be blocked into our region and held into our region, which allows below average temperatures to occur and hang on for a longer period of time. So breaking down the North Atlantic Oscillation, NAO, the negative NAO is one of the best predictors for an East Coast trough or a dip in the jet stream, which will allow for colder than normal temperatures to set up and then stay for a little while, which enhances the potential for nor'easters and other storms that could bring snow to the area. Once again, this is not going to be something that can be predicted on a seasonal scale. So it's not going to be something where we're going to be able to lock that in for more than a week or two in advance. Lastly, while the negative NAO is a good predictor of colder than normal temperatures, that is not a good indicator of whether we're going to get snow. It's just basically saying that we are getting into a colder period. So your mileage may vary, as they say. Next, we'll talk about the Pacific North American pattern, which typically will set up with the upper level flow and the upper level heights in the western United States. A positive PNA will tend to allow for ridging in the west coast, which will allow for troughing to occur downstream over the east here. A negative PNA allows for east coast ridging, which would be a warmer pattern for us, and a colder situation out west. Now you look at the climatology for that December through February period, and again, El Nino, Enso neutral, and La Nina are typically pretty good indicators of the temperature departures in terms of cooler than normal in an El Nino, near normal in a neutral type of pattern, and then warmer than normal in a La Nina. With NAO and positive PNA, we can see that the temperature departures are a lot more stark, whereas we have a negative NAO and a positive PNA. When we have those, ideally when we have them together, we can kind of lock in colder than normal values across our region when they do occur. So this is kind of a better setup to kind of lock in that cold air, and kind of a good harbinger when you see them setting up a week or so in advance. You can kind of say, okay, we're getting into a colder pattern with a good amount of certainty that that's going to be the case. All right, so looking at the Climate Prediction Center webpage, the CPC page, again, you can be able to lock in the outlooks. This will get into a little bit more of the teleconnections in both the 6 to 10 and 8 to 14 day. They'll lock in some of those teleconnections in there. The remainder of those are going to be more seasonal, which is going to be relying on what we've gone through already. So thanks so much for your time. We talked a little bit about climatology today. Hopefully that made things a little bit clearer for you. For more information, certainly look at the CPC Outlooks on YouTube and on their webpage. They also have more information on ENSO and the teleconnections on their web pages. And then also keep an eye on our climate page at the URL that you see there. We'll be talking about mid-Atlantic snowstorm patterns in our next portion. Thank you so much for being part of our presentation today, and we'll see you next time.